So one of the things we all kind of know is if you drop an object, like you see Galileo doing here, dropping an object off of the Leaning Tower of Pisa, you know that that object is going to fall to the ground, and that's the force of gravity. We've talked about this idea that basically we have the center of the earth down here. We have a mutual attraction of objects. Now, Galileo didn't necessarily know that, but one of the things that Galileo proved was that regardless of the size of the mass, that it's not only going to fall to the earth, but it's going to fall going faster and faster and faster, okay? And the deal is that regardless of the mass of the rock, and here he's got two different sizes of rocks, a smaller rock on the left and a larger rock on the right, regardless of the mass of the rock, it's going to accelerate at the same speed. So it's going to go faster and then faster and then faster yet, but they're going to go be neck and neck. So that is pretty darn cool. That the rate at which it accelerates, assuming that you're saying that its speed is in meters per second, is that for each meter it falls, it's going to go 9.8 meters per second faster. Now, that's the rate at which it accelerates as it falls down. So 9.8 meters per second. Oh, I said for each meter it falls. I'm sorry. For each second it falls. For each second it falls, it's going to pick up 9.8 meters per second. So that's why we call it 9.8 meters per second for each second it falls, otherwise known as 9.8 meters per second squared. That's the acceleration due to gravity, and we use the lowercase g for that. So this is just kind of expounding on that, and I have a video for you to watch here in a minute to kind of prove that. But we have a little experiment down here. This is a chamber to which the air has been evacuated. There's kind of a little tube there that basically sucked all the air out. And so there's no air in here. And dropping two objects, the feather and a penny or a coin, they have different masses and actually they have different aerodynamics. In air, you would say that the feather would just kind of float down gently and the coin would kind of drop like a rock. Well, that kind of has to do with the air resistance as it falls. But now, remember, in this chamber, we have removed all of the air. So now we just have two objects that are going to fall faster and faster as they accelerate towards the ground. And we see that they actually hit the ground at the same time. So, yeah. So I have a little video for you to watch, and we'll call it a day.